Hey guys! Today we're going to talk about Chapter 9, 1, Identities and Proofs.
Okay.
Here we go.
All right, so what is an identity? An identity is an equation that is always true for all variables, okay, in which every term of the equation is defined. All right, now first thing we're going to do is show graphically that an equation is an identity, and when we do that, we're going to take each side of the equation and graph it as its own function, and then we're going to look at how it looks. Now it says be sure to make one bold. Here's the thing, you're going to see on our graphs, you're going to see colored graphs. You don't have the calculators that do that. If you want to bring your calculator in, we can show you how to change how your graph looks so that one of your functions would graph bold. And the reason you would want to see that is it lets you see when it graphs the one with a bold line if it's going right over the one that you've already graphed. You'll understand that in a moment. All right, so here we have, let's look at A. Okay, try not to look at anything that you see, but we're going to graph 3 sine squared x. That was in our f1 of x, 3 sine squared x plus 2 cosine x. And this is in our f2 of x. Oopsie, not what I just wrote.
Okay, and you can see the red graph is f1 of x, and the yellow graph is f2 of x, okay? And notice that they don't intersect at every single point, so this is not an identity. In order to be an identity, they have to intersect at every single point.
So this is one where, as far as making your function graph bold, it's not going to matter. Now, let's look at the next one. Oopsie, not that. Okay. The next graph, what we have done is we have graphed, once again, this is in f1 of x is in red, okay? And f2 of x, sine x plus cotangent x, is in green. So you'll notice that right here is our first graph, okay? That is our f1 of x. You can see how it looks. And by the way, you can tell what the window is, so you can graph it yourself.
Negative 2 pi to 2 pi and negative 10 to 10.
For this one, and this one goes negative 3 to 4, the first one. All right, now, notice that when we graph the second one, the green graph, we don't see the red graph.
The red graph all but disappears.
But we still see the red graph equation. So what you're seeing, and when you graph yours, you're going to probably think it's not graphing, but when you see both functions on the screen, you'll know that both of them have actually graphed. Again, we can show you how to make your second graph a bold line so that you can see that it actually, when it graphs, is laying right on top of the other one. But, so
this is an identity. Since every point is an intersection of the two graphs.
All right. So now what we're going to do is we are actually going to do the work to show with our function, with our theorems and things that we know, our identities, our other previous identities, we're going to show that what we just did, why it is an identity. All right, which means we are going to show one side to look like the other side. Okay, important. No work done across the equal sign.
You can't add something to both sides, and you can't subtract something from both sides or divide something from both sides. You have to treat each side separately.
So what we do when you're looking at a proof, we're going to do a proof. That's what this is. And when you look at an identity and you say, well, now which side do I work with? You want to start with the side that looks more complicated because it has more stuff you can do to it. All right? Now, there's several ways we could go about doing this first one, but let's notice that we have an identity that can be grouped together if we group the 1 and the cosine squared. So I'm going to rewrite this as 1 minus cosine squared of x, okay, plus the cosine x. I'm just rearranging it, and this is all over sine x, okay? Well, when we do that, what do we know about 1 minus cosine squared of x?
That's sine squared x.
That is one of our versions of the Pythagorean identity, and you really, really need to know those. Okay, over sine of x. Now we can do something really nice and cool. We can write this as two separate, one combined fraction, oopsie, one combined fraction means you had two fractions with the same denominator before. Just going back to middle school and doing things that we know from middle school.
since it's just one thing in the denominator.
Yeah. All right, now, what do I have here? We have sine squared x over sine x. That gives us sine x. Plus, and what is cosine x over sine x?
Cotangent x.
And look, that is what we wanted to show. The way you do a proof, you make one side equal to the other. Okay, you work them vertically, and all along we are showing that the left-hand side equals the right-hand side. That is what we're trying to prove. Okay?
Okay.
Now, we just did our first identity proof, and we're now going to just rename that as example 2. Now, you need to remember all the nifty identities you learned in section 6.5, and you want to go, you could go to section 5, page 574, and look at the wonderful yellow book boxes that take up the entire page.
What I would do is I would go ahead and write them out on my own, so that whenever I'm ready to write my tip sheet that will be due at the end of the semester, I will already have them in a nice place tucked away, so I just have to copy them to my tip sheet.
There you go. Okay.
All right. So this one we're just going to simplify. All right. So what we're going to do here. Okay, here we go. Notice this is 2 binomials. So we're just going to go ahead and FOIL this nice little binomial thing here. We have secant x plus tangent x times 1 minus sine x. So the first 2 things we're going to multiply are secant x and 1. So that's just secant x. The second 2 things we're going to multiply are secant x and negative sine x, which is negative secant x sine x.
Okay.
What? We're going to rewrite it as sine over...
Yeah, go ahead. Keep going.
Then we've got the inners.
Okay.
And that's plus tangent x. And then our last 2, which are tangent and negative sine x. This is minus tan x sine x. There we go. Okay, now
I'm going to be I like to do my little thing underneath, so she's going to keep going.
Okay, she likes the happy tomato.
I like the happy face. When you foiled right, you have a nice little face. You got the eyebrows
Happy
and the
tomato.
ears and the nose and the mouth and the chin. Okay.
Okay, so now I'm going to use my identities that I know, my reciprocal identities, to get everything in terms of sine and cosine.
Oh, and by the way, you'll notice that there's no equal sign. So when there's no equal sign, what we're trying to do is get your problem into terms of one function only. Okay?
All right, so first, let's get it to sine and cosine and see what we can do from there. So secant x is 1 over cosine of x. Okay. Minus secant x is 1 over cosine of x times sine of x. Tangent of x is sine of x over cosine of x. And this is sine of x over cosine of x times sine of x. Okay, now I just replaced each thing that could be changed to a sine or a cosine into those things. I haven't multiplied anything really.
And notice, this is a reciprocal identity. This is a reciprocal identity. This is a quotient identity. And this was a quotient identity. It's good to know what types of identities you're using.
Okay, so now I'm going to go ahead and rewrite all these fractions so that I can have one denominator, because it looks like everything has a denominator of cosine. So this is 1 over cosine x minus sine x over cosine x plus sine x over cosine x.
Ooh, ooh!
Those can be added together.
And dropped out eventually.
Oh, this is minus, yes. So look, we've got a minus and a plus, so those are going to go away. All right, and then this is minus sine squared x over cosine x. All right, so let's go ahead, and we've already dropped out the 2 middle terms because they went away. So we have 2 with the same denominator, so I'm going to combine those 2. 1 minus sine squared x over cosine of x.
Hey, that's a Pythagorean identity on top.
All right, so 1 minus sine squared x equals cosine squared x over cosine of x, which equals cosine of x. And we're done. All that nastiness went all down nicely to cosine of x. Isn't that sweet?
Yeah, and notice we're not really doing an equation. We're just trying to simplify this, so you got to be careful about how you use those equal signs. All right, next. Oops, ET problem.
Go to section 9.1 and work 2, 4, 10, and 14.
2 and 4 are graphs, so those shouldn't take you very long.
You just graph them on your calculator and sketch.
Yeah. Okay, so here we go. This one we're going to do 2 different ways. Now, this is very important. Contrary to the way some of the proofs are going to be done in the textbooks, we will not perform algebra across the equation. I don't really know why that happens, so ignore how the textbook does it. Therefore, if you're a person using a tutor in the textbook instead of the videos, too bad for you.
But what we do want you to do is look at the book and see if any of the problems in the book you can do, because that's where some test questions might come from.
Okay, so again, what I told you before, when you have an equation, you're proving an identity, you want to see which side looks more difficult. So they both kind of look difficult. They're both fractions. One's got a binomial in the denominator, one's got a binomial in the numerator. So we're going to start with working down the left-hand side. That's the one we're going to do. Now, we're going to do something creative, multiplying by a creative form of 1. We're going to take cosine x over 1 minus sine x. And I would like to multiply this by the conjugate of 1 minus sine x.
Conjugate! Conjugate! Multiplied by the conjugate!
And why do we do that? You should see that on the bottom, we immediately can go to 1 minus sine squared x, because that's going to give us a difference of 2 squares. Okay? On the top, what I'm going to do is leave this factored, because I am hoping that something is going to cancel. Okay? Now, what do we know about? Notice on the bottom.
It's cosine squared x.
Oopsie. So, we're going to write cosine x times 1 plus sine x. You could distribute, but the thing about it is our goal is going to be to make this look different, so it's probably better to, at this point, not cancel. Not distribute. But now you can see that we can cancel. And do you notice that this cosine here is going to cancel with one of these here, and it is going to leave 1 plus sine x on top. Let me redo this here. So I have 1 plus sine x on top over the remaining cosine x. And
which is that?
That is what we wanted to prove. And this is how you do the proof. Okay? And so you can actually keep the equal signs going because we are working the left-hand side down. All right? Now we're going to do it the other way and work the right-hand side down. That means the left-hand side is going to stay the same, and we're going to try to get the right-hand side to that. Okay? So, you want to do it?
All right. So this time, notice that our nasty stuff is on the top. So we have 1 plus sine x over cosine x. And honestly, I don't know why I would multiply. Well, you know what? I could multiply by cosine, but
multiply by the...
I'm going to multiply by the conjugate.
Of the numerator.
Of the numerator, because I want to make it nice and simple. So I'm going to multiply by 1 minus sine x over 1 minus sine x. And that gives me 1 minus sine squared x on top, and on bottom, again, I don't want to factor it or distribute it, so this is cosine x times 1 minus sine x. Okay, well, 1 minus sine x by the identity is cosine squared x over cosine x times 1 minus sine x.
She meant 1 minus sine squared x is cosine squared x. You know what she meant.
That's what I meant. Okay. I was thinking too fast. All right, now one of the cosines on top can cancel with one of the cosine on the bottom. So this gives us cosine of x over 1 minus sine of x, which is the original piece. 1, equals 1, cosine of x over 1 minus sine of x.
Right, so what we want, again, when you do a proof, when you do an identity proof, you have to work one side all the way down, and your last step, the last step is to show that the left-hand side equals the right-hand side. If you don't do that, you have not completed the proof. All right, now we're going to do this one. Which side looks more complicated? Well, You know, the right-hand side looks complicated. We just did a proof where we did something with the right-hand side, but anytime you have secant and tangent, that's probably more complicated than the other. So let's use a quotient identity for secant, 1 over cosine x. Let's use a quotient. That's wrong. That was a reciprocal identity for secant. Now let's use my brain's going faster than my hands are too. Quotient identity for tangent, that's sine x over cosine x. By the way, it's good to tell us which side you're going to work. We're going to work the left-hand side. That way you stay focused. Now, what do we have here? We have got common denominator.
Yeah, common denominator.
1 plus sine x
over cosine
x. Oh,
let's do exactly what we did last time. Let's multiply by the conjugate of the top. Woohoo! Woohoo! Oh yeah, conjugate. Do the conjugate dance. Conjugate dance.
And so the top we recognize as a difference of two squares. The bottom is, again, we're going to leave it.
Cosine x. You can't have a cosine without an angle.
Unless we were doing the cosine of.
Yeah, but we're not doing the cosine of 1 minus sine of something. That's nasty.
So, cosine squared, but in some college class you might, so. Cosine of x, 1 minus sine of x. The cosines cancel, and you are left with, on top, 1 cosine left, not cosecant, cosine. And on bottom, you're left with 1 minus sine x, and we see that the left hand is exactly equal to the right hand side, and we are done.
We expect you to show every single step. Do you see that we did not just magically go to the end once we saw that we could multiply by the conjugate? We want you to show us every single step of algebra.
Yeah, and sometimes, you know, sometimes I have my students actually put in parentheses which identities they're using. It helps them to learn the identities better. Okay, this one looks awful. This is our last one for today.
All right.
It looks pretty horrible.
Yeah, but which one's nastier? Well, the one with secant is nastier because secant is not one of our sine cosine nice ones.
Yeah, and that's not an identity that is either. We can't even use our Pythagorean identity that secant squared is 1 plus tangent squared. We can't do that. What we can do is, you see on the left side the cosines, so maybe we can do something on the right side with secant. And so what can we do with that?
We can do our reciprocal identities.
Yeah, so we can do 1 minus, and instead of secant, we're going to write 1 over cosine of x on top, and 1 plus, instead of secant, we're going to write 1 over cosine of x on bottom. Now, some of you may say this looks horrible, but you know what? It does. Sometimes your work gets a little more horrible looking before it gets done. And so what we can see now is we have a complex fraction, and how can we make that complex fraction better? We can make this better by taking that fraction and multiplying by the common denominator. Look at all of our denominators. Our common denominator, our LCD, is cosine of x. So if we distribute across the top cosine x, and we distribute across the bottom cosine x, okay? The whole purpose in doing this step is that all of the fractions in the fraction go away. This is an old Algebra 2 concept. We started it again at the beginning of the year, so you should recognize it. So when we do the cosine x times the 1, we get cosine of x, minus when we do cosine x times 1 over cosine x, we get 1. Hey, that's actually what we wanted in the numerator of the problem. So let's see what happens when we distribute cosine x across the bottom. We get cosine x times 1, which is cosine of x, and then cosine of x times positive 1 over cosine x, which is plus 1. And look, we have the left-hand side equal to the right-hand side.
Yay!
So we're done. So again, the thing that you're looking at here is you want to take the one that looks more complicated, and sometimes in the process of taking the one that looks more horrible, it even gets more horrible looking, but then it turns into beautiful.
And I usually try to do something that gets me to sine or cosine. If I am completely stuck, I try to get into sines and cosines because those are things I can use my identities more readily.
Yeah, that's a good point there.
So if you're completely stuck, pick the side that doesn't have sines and cosines and make it have sines and cosines and see what you can do. All right. And next you're going to do number 20 and 26. All right. One new thing you learned, email me that, and one good question, and 2 old skills that are important to recall for this material.
My students, don't email Ms. Miller, email me.
No, yeah, email Ms. Doxter. Don't
Actually,
email me.
You can lighten my workload. Email them all to Mrs. Miller,
No,
and then
okay.
I don't have to do any work. Yeah, I like that.
No, that's not good.
Have a good day.
Bye.